Okay, I wanted to talk a little bit about expected remaining lifetime because I got tripped up the other day when I was reviewing one of the formulas for it. Um, let's start with CRTATE, expected remaining lifetime. So that just means we're looking at discrete values that the future lifetime could take on. Um, so CRTATE, expected remaining lifetime, looks like that. I'm just going to look at all the different values that the future lifetime could take on and their corresponding probabilities, and we'll take the expected value, and that is the expected remaining lifetime. So you could live one more year. If you only live one more year, the probability of that is that you live 1 year, that you fail to live the next year. You live 1 year and then you die. Okay, that's one. Two would be you live 2 years and then you die. Three would be you live 3 years and then you die. And on and on and on. So we want to multiply, if we're taking the expected value, we're going to multiply 1 by its corresponding probability plus 2 times its corresponding probability plus 3 times its corresponding probability, okay? And we get the sum, k goes from 1 to infinity of k for each value that the future lifetime can take on times the probability that you live that many years and then die. Okay, that makes perfect sense. Out. Now, and in the same way, if we want to do continuous remaining lifetime, continuous expected remaining lifetime, okay, that just gets the little circle over it. We're still really doing the same kind of thing. We're just taking expected value, but now it's continuous, so some things change a little bit. So we want to take the product of all the values that the future lifetime could take on and their corresponding probabilities and sum those up to get the expected value. So the values that the future lifetime will take on, we're going to call it T now instead of K because it's continuous. So it's the value that the future lifetime can take on times its corresponding probability. Well now, since it's continuous, we're going to use the probability density function for the future lifetime at T. And we know that that is TPX mu x plus T. Okay, now we just want to sum all this up. It's continuous, so we're going to integrate. And it's for the rest of their lives, so future lifetime from 0 to infinity. So really very similar to the CRTATE case. Where I got mixed up was in the n-year expected remaining lifetime. So let's say we're looking at a 5-year temporary CRTATE expected remaining lifetime. So what are the possible future lifetimes? It could be 1, 2, 3, 4, and 5. Okay, so just like last time, probability of living 1 more year is you live 1 year and then you die. Of course, same for 2, 3, 4. Okay, but the probability that your future remaining lifetime is not just 5, because we don't see what happens after 5. So it's actually just going to be, it's 5 or anything after 5. Because if you live more than 5 years, we only see a 5. So it's going to be the probability that you survive 5 years, 5px. Another way to look at that is if you understand all of these, you know that these are all the possible values that the future lifetime could take on. All their probabilities need to add up to 1. So this will be 1 minus this, minus this, minus this, minus this. Okay, hopefully that makes sense. Okay, so the n-year temporary her Tate expected remaining lifetime for X. Looks like that. It's going to be the sum of all the values that K can take on up until just before that last one. So whatever n is minus 1, K goes from 1 to n minus 1, or here 4. The value that the future lifetime can take on times their corresponding probabilities. And then we have this last 5. Here it's 5, in general it's n, times npx. So plus npx. And this is the part that I was forgetting about. I was just kind of thinking that it would be the same as for whole life, except you just cut it off at n. Okay? Not true. In fact, on a red marker. Not true. And hopefully you can see why that's the case. And then for continuous, again, it's very similar. Now you're still looking for expected values, so we want to take all the possible values that the future lifetime can take on times their corresponding probabilities, which is the probability density function for x evaluated at t, which we said before is mu x plus t. We want to sum all those products up to get the expected value. But now we're only going to want to go up to n because it's continuous. We don't want to put n minus 1 because then we're going to miss everything between n minus 1 and n. So we're going to go right up to n. This is the continuous temporary expected lifetime. Okay, and then just like with her Tate, we have to add back in this n times npx. I'll leave myself that. So maybe that's already very intuitive to you. That was something that I missed the first time around. So hopefully that helps. And good luck and happy studying.